Good evening, students. Today let us solve some of the questions related to your equations of motion for constant acceleration. The equations of motions that already I have told you what are that. If the acceleration is constant, you can apply that equations. So let us see how and what equations we can apply and how we can apply. So let us solve a very simple question. A car starts from rest with an acceleration of 3 meters per second square and makes a run for 35 seconds. What is the length covered by that car? What is the final velocity after 35 seconds? This is a question, simple question given. So in this question, let us write down what are the data provided to you. First data, it is given a car starts from rest. Rest means if for you your time starts from there, then at t is equal to 0, your u is equal to 0, means it is at rest. U refers to your initial speed, which is 0. Value of the acceleration is given is 3 meters per second square. 3 meters per second square. And makes a run for 35 seconds. So time is given. T is equal to 35 seconds. Now you see here time starts from 0 at t is equal to 0. Your u is equal to 0 means initial speed given. Acceleration given, time given. What is the length covered? Length covered means actually distance covered by the object. So we need to think distance, acceleration, time, they are related by which equation? So we have basically 4 equations here. V is equal to u plus at. S is equal to ut plus half at square. V square is equal to u square plus 2as. And another equation is for s nth, that is u plus a by 2 whole into 2n minus 1. So out of the 4 equations, which equation is applicable here? Length covered means distance. So our equation must contain a acceleration, t, initial speed and your distance. So this equation is there. The second equation is equal to ut plus half at square. So you choose your equation. Now I can put the value over there. S is equal to ut, u is your 0 into t is 35 plus half into a is your 3 into t square means 35 square. So this is the length covered, means 0 into 35 0 plus half into 3 square of 35, which is 12 to 5. Now your value is how much? So 25 3 75, 6 and 3 divided by 2, this much meter is your distance covered. Now the second question, what is the final velocity after 35 seconds? Means first case you are asked to calculate s, in the second case you are asked to calculate v, means at t is equal to 35 seconds. When the time is 35 seconds, you are asked to calculate the value of your v. Now which equation you need to take? See, this equation relating v square is equal to u square plus 2as. Acceleration you know, distance already calculated. This equation you can take, and the simple equation you can take here, v is equal to u plus at. V is equal to u plus at. This is a simple equation you can take to calculate your v. Since u is equal to 0, v is equal to simply a into t. So your second equations, I can take the first one, it will be easier for you because here square terms are there, so it will be difficult to calculate. So now it's better you calculate your v, in this case c. Now you see here v is equal to u plus at, u is 0, a is your 3 and t is your 35. So which is your 105 meter per second. S is equal to this by 2, V is equal to 105 meter per second. So this is the way by which you will choose your equation. This is a very simple question. This question you can modify in a other way. Like suppose in this case you are asked like this. So at 35 seconds the car applies, or the driver applies a brake. So the car comes to a stop, and the acceleration in that case, let's say at the acceleration is your 6 meter per second square. Once the driver applies the brake, let's say the acceleration is 6 in that case. So after what much distance the car will comes to a stop? The question is, if the driver applies the brake after 35 seconds, what is the distance covered for the car to comes to a stop after 35 seconds? Got? So that is the most important part here. That distance is called stopping distance. So if you figure out this question, the car starts from rest, it has moved to this point when the time t is equal to 35 seconds. Let's say this distance is what you got, that is your s. At this point the speed after 35 seconds is your 105 meter per second, and if the car applies brake here, suppose after coming to a stop, it will move this distance d. So this distance d is called your stopping distance. Stopping distance. Try to understand. So at this point I have applied the brake, but the car will comes to a stop at this point. So means some distance I will move, let's say that is s dash. What? So here the acceleration is given, it is 6 meter per second square. Try to understand here. From this point to this point, let's say the point is A. From here to here, the car accelerates at 3 meter per second square. Means here the speed is 0 and here the speed is V is 105 meter per second. And at this point the car applies brake, and at this point it is coming to a stop, means here the final velocity is 0 here. Got? So this is a case where the speed of the body from 0 to means OA, it increases. So here you need to take the acceleration value to be your positive. In this case the object is applying some brake, so speed decreases from 105 to 0. So in that case you need to take your acceleration, that is otherwise called deceleration or negative acceleration. Got? So this is a part, if you see in your diagrammatical, if you want to see, this is the part 0 to O means O to A, where the velocity and acceleration, they are in the same direction from O to A. From once you have started applying brake, your velocity is in this way and acceleration is directed opposite from here to here. This is the case. So since velocity and acceleration, they are in the same way, in this case you need to take acceleration positive. And in this case velocity and acceleration, they are opposite, you take acceleration to be negative. So now let us calculate the stopping distance. The question here is asked to calculate the stopping distance. To calculate the stopping distance, you see your initial velocity given. Initial velocity, though it is v, we need to take for this part A, let's say the final is your C. Between A and C, the initial velocity here it is v, which is in general it is taken to be symbol u by your symbol u, which is 105 meter per second. And here the final velocity v is your means v dash, which is 0. Got? So u given, v given. Got? And acceleration given. A is your minus 6 meter per second square. UVA given, we need to find out the distance. So the simple equation is this equation we need to take. V square is equal to V square minus U square is equal to 2A into S, which implies S is equal to V square minus U square by 2 into A. V means your final velocity, which is 0 in this case. What? So 0 minus U square. U is how much? U is your V, which is 105. So which is 105 square divided by 2 into 6. Since it is A is minus, so you take minus in this case. So which implies your S is equal to square that is 25, 11 into 10 means 11025 minus divided by minus 12. So if you calculate, you are going to get minus minus plus. So 11025 by 12 meter is your stopping distance. Now students, second question you take, the question number 2 here. The question is, a body covers 12 meter in 2 second, 12 meter in second, not 2 second. A body covers 12 meter in second and 20 meter in 4th second. Question is, how much distance will it cover in 4 second after 5th second? Try to understand here. 12 meter in second. Second means what? That day already I have told you. Second means this is the distance moved in between 1 second and 2 seconds. That is called your S2. We can say S second, that is your S nth. In general, that is called your S nth, means it is the distance moved between time 1 second and 2 seconds. Similarly, 20 meter it has covered in between 3 second and 4 second. That it is given. So we can write here S second is equal to 12 and S fourth is equal to 20. Means in general, the formula is S nth is equal to U plus A by 2 into 2n minus 1. Here n stands for the time. What? N stands for the disposition of your time. Got? Try to understand the question. The question here is asking you how much distance will it cover in 4 seconds. Got? But that 4 seconds is after your 5th second. Means if from here the object has started the motion, the time t is equal to 0, it is the time when t is equal to 5 seconds. So after 5 seconds means this is the 5th second. 0th second, this is the 5th second. After the 5th second, in 4 seconds means here t would be your 9 second. So in between t is equal to 5 second and t is equal to 9 second, what is the distance covered? It is asking. So it means if you know this total distance, that is your S9, and from here to here the total distance is your S5, then if we subtract S9 minus S5, we will get that 4 seconds after your 5th second distance. Try to understand here. S9 and S5. If someone has written S9th and S5th, these two are different. S9, this symbol stands for the distance covered by the body in 9 seconds, means from here to here. S9th means it is the distance covered by the body between 8 to 9 second, means only in 1 second, but that 1 second is in between 8th second and 9th second. Got? So it is your S nth and it is your simply S distance. S nth is what? It is the distance covered by a body in the nth second. Nth second means suppose a body is moving for 10 seconds. Got? So here n is equal to 10. Here S 10th means the distance moved by the body between 9 second and 10 second. Means during that 1 second, what is the distance covered? That is called your S 10th in this case. So there is a gap, huge gap between Sn and S nth. So don't be confused. So now according to our question, we need to find out S9 minus S5, because the question here, you read the question carefully, how much distance will it cover in 4 seconds after the 5th second? Means between this 4 seconds we need to find out the distance. So means total time span is your 9 seconds. So S9 is the distance covered in 9 seconds minus S5. S5 is the distance covered in 5 seconds. So it is the distance covered in this part is the distance covered in 4 seconds after 5th second. So we need to find out S9 minus S5. Got? So before going into that, so let us see what are the data provided to us. Only these two data provided to us. So here S nth is equal to u plus a by 2 2n minus 1. This formula definitely will apply because it is given. In this case it is second and that so 4 second data is given. Now I can apply the formula S nth is equal to u plus a by 2 into n minus 1. This is unknown. Your initial speed is unknown, acceleration is unknown. Only here in this case the time is given. So this equation will be u plus a by 2 into, see here it is S nth and here it is n, means both are the same time. So it is second means time, instead of n you take 2 minus 1. So which is equal to, the equation would be u plus a by 2 into 2 4 minus 1 means 3. 2 into 2 4 minus 1 3. So it would be 3a by 2, equation number 1. In this case the same similar way, u plus a by 2 into, it is 4 minus 1. So which is u plus 2 into 4 into 4 8 minus 1 7. So which is 7a by 2, which is equation number 2. Now you see here two unknown, u, a, both are unknown, two equations are there. So we can solve that equation. So let us write it here. Simply 7a by 2 plus u is equal to 20 and 3a by 2 plus u is equal to 12. Now I can subtract this 2. If you can subtract this 2, we are going to get 7a by 2, 3a by 2. So which is, it is minus, minus, minus. Now subtractions, this minus this, which is 4a by 2, u got cancelled, which is equal to 8, which is 2a. So which implies 2a is equal to 8, a is equal to 4 meter per second square. So you got the acceleration from this equation. So you take this value of acceleration, put in any equation, you will find your answer. Suppose you take acceleration to be 4 in this case, which implies 20 is equal to u plus 7 by 2 into 4. So which is 2 if you divide it. So which implies u is equal to 20. Here it is 7 into 2. 7 into 2, 14. 7. So which is your 20 minus 14, which is 6 meter per second. So now from these two equations we got the value of your acceleration and your u. U means initial speed. That we will note it down. So here u is 6 meter per second and acceleration is 4 meter per second square. Now let us solve it. Now let us solve our answer. Our answer is what? A is 9 minus A is 5 we need to find out. Now you see, S, we know S is equal to ut plus half at square. This formula we are applying because it is the distance covered in t time. That's why we put this formula. Similarly, S9 means distance covered by the body in 9 seconds. So first case you take t to be 9, u and a value you put it there. So S9, if I will take u is your 6, t is your 9 plus half into a is your 4 into 9 square. First case, 9 square is 81. Or square of 9 you write first, then the second step you will do. So it will be 54 plus 2 into 81. So which is 54 plus 212, so 162. So which is, now you can add this 2. So this is 216 meter. Now we need to calculate S5. S5 similarly, ut plus half at square. So u is your 6, t is your 5 plus half into 4 into 5 square. Because here in this case t is equal to, second equation, t is equal to 5 I am taking. So which is equal to 6, 5, 30 again. So which is 2 into 25, 30 plus 50. So which is 80 meter. Now our answer is S9 minus S5, which implies S9 minus S5 is equal to 216 minus 80. So which should be 6. So means 136 meter is the distance covered during this time. So this is the second typical question that you need to understand, students. Okay. Let us solve a tricky question, simple but tricky. The question number 3. The question is, a man is 9 meter behind the door of a train. When it starts moving with acceleration a is equal to 2 meter per second square. The man runs at full speed. How far does he has to run and after what time does he get into the train? What is his full speed? So try to understand the question. A man is 9 meter behind the door of a train. So here I have drawn the diagram. Suppose you take this to be your train. This is your train, and this point O is your there is a man here. So this is the door of a train, and the man is 9 meter behind the train, and the train is moving in this direction with acceleration is equal to 2 meter per second square. The man is chasing. The man is chasing the train. Means when this gap the man will be able to cover, then he might get a chance to get into the train. Got? Suppose, and see, to cover the 9 meter the man will take some time, and in between that time the train will not be here, it will come to this point. This is the point I have taken. Here it is the train's position. This is the man's position. Here let us, the time is t here, and the speed of the train is v. And see, since the man is moving into the train, the speed of the man also must be same that of your train. The speed of the man at this moment and the speed of the train, they must be equal. Let us say that is your v. So remember, since the man is intending to move into the train, means at a particular time their position must be same, also their speed must be same. So that is the key idea here that you need to remember. Got? So what are the data given to us? The train is moving with an acceleration and it starts from u0. So the initial speed of the train is 0, and once it started, so it started with an acceleration. But what the man is doing? The man is doing means it is running at its full speed. So it means the man is running at a constant speed. Got? So it means whatever be the speed of the man here, the same speed of the man must be here. Because the man is running at its full speed, which is a constant. The full speed, the ultimum speed of a person is a constant one. So the speed of the man at this moment, if it is v, then the same v will be here. So the key idea is here, means at a particular moment when the speed of the man is equal to the speed of the train and the distance covered by the man is 9 more than the distance covered by the train, because the man is 9 meters behind the train. This thing we need to consider. Got the point? Means this is the first position of your man, which is 9 meters behind the train. Train is covering this distance, which is your STR. Since man is intending to enter, means he has to cover extra 9 meters. Means distance covered by the man should be STR, means distance covered by the train plus 9 meters. Now let us calculate the motion. Let us consider the motion of your train. So let us calculate what is the distance covered by the train. Train is in accelerated motion and man is moving in a uniform motion, uniform speed, means non-accelerated motion. So the data I have mentioned here. The acceleration of the train is 2 meters per second square. Initial speed of the train is 0, it is given. Acceleration of the man is 0 and the man has started its motion at a full speed. Let the full speed is v. So for the train's distance covered by the train during the time t, got, which is s is equal to ut plus half at square. As u is 0, I have put it 0 here. So 0 into t plus half. Acceleration of the train is 2. So 2 got cancelled, means STR is equal to t square. Let us take to be equation number 1. Now let us calculate what is the distance covered by the man during the same time. So we can apply this equation. Again, s is equal to ut plus half at square. S is equal to um into t, means initial speed of the man into t plus half acceleration of the man into t square. As the man is in uniform motion, so its acceleration is 0. So your equation would be Sm is equal to v into t. Why vt? Because initial speed of the man and final speed of the man are same, which we have taken it to be v. So Sm is equal to vt. Now equation 1 and 2, they are related here. Str plus 9 is equal to Sm. Already I have discussed. So I have put it here. So instead of Sm, I took equation 2, which is Vt. Instead of Str, I took equation 1, which is your t square. So V into t is equal to t square plus 9. Now the key factor is here. See, we got the time and we got a variable v. In one equation, 2 variables, so this cannot be solved. So we need to rethink. So what to substitute so that this can be reduced to a one variable. Now consider this v. Already I have mentioned at this point the speed of the train and the speed of the man both are equal. So in that case we can calculate the speed of the man at this moment v, because this train is accelerating and its initial speed is 0. So, and we know the formula v is equal to u plus at. So this v is equal to u, means u of the train, which is 0, plus acceleration of the train is 2 into t. So which implies v is equal to 2t. We can take, let us take it to equation number 4. Now take this equation and put it here, and that equation 3 will become, if you put v is equal to 2t So 2t into t is equal to t square plus 9, which implies 2t square is equal to t square plus 9, which implies 2t square minus t square is equal to 9, which implies t is equal to 3 seconds. If you see, so means here t square is equal to 9, it means t is equal to 3 seconds. So now we got the answer. What time does he get into the train? After what time does it means after 3 seconds the man will enter into the train. How far does he has to run and after what time? How far means what is the distance covered by the man? So that we can find out Sm. Sm, this formula. So before Sm is equal to how much? Str plus 9. So we can calculate Str. Str is, we have calculated Str is how much? Str is your t square. Str is your t square. So t is 3. Got? So which is 3 square plus 9. So means 3 square is 9 plus 9, 18 meter. Got? As Sm is your t square plus 9. Sm is t square plus 9, so which is coming to be your 18 meter. And the last answer is, what is his full speed? Whose full speed? Means the man's full speed, also the train's full speed. That we can calculate. The full speed of the man, v is equal to 2t. So v is equal to 2, t is your 3, so which is 6 meter per second. So your answers are like this. So in this case, the man, how far does means this answer is your 18 meter, and after what time means t is equal to 3 seconds, and what is the full speed? This answer is your 6 meter per second. But so this is the approach of your question you need to follow. Thank you, students.